Hello. Good morning, wherever you are. Today I'm using my new digitizer, so I can write a bit easier. So if I go a bit slow, it's just because I'm getting used to this new bit of thing. Because I can write now. Watch this. Click. So today we're going to be doing a bit of calculating angles. And don't go all moon because we're doing engineering, so you need to know about angles. So obviously we're going to be using, you should have known this before, so sine, cos, and tan. And you should remember that, see if I can draw a shape, is my triangle, hopefully it'll kick in. Nope. Okay, don't like that. Let's get rid of that. We're getting used to the, let's try again. Straight up, straight down, just come on, get in. Sort of a triangle there, sort of a triangle. So we should know that, give it that perhaps, that if I've got an angle here and I want to find that angle, this side here is opposite the angle. This side here is adjacent to the angle. And this side here, the longest side of the right angle triangle, is a hypotenuse. Don't forget we've got 90 degrees there. So, SOHCAHTOA, SOHCAHTOA, so different color. So sine of the angle is going to be opposite over hypotenuse. So if we know the opposite and we know that if we know the opposite and we know the hypotenuse, we can use a sine to find out the angle. And then see if I can do this. Get in. And then we can also do if we know the adjacent and the hypotenuse, we can use cos of the angle equals adjacent over hypotenuse. Because opposite hypotenuse, right? So there's the H, there's the O, and there's the A, just in case. So if we know the adjacent and we know the hypotenuse, we can work out the angle with cos. Or if we know the angle, we can work out the sides. But today we're just doing angles. And then if we only know the opposite and the adjacent, we can do tan of the angle is opposite over adjacent. So hopefully you should have somewhere in your past, this shouldn't be new to people if you've done a certain level. So SOHCAHTOA, so sine, cos and tan. So on your calculator, sine, cos and tan. So we'll just do some examples on that. Let me go to a new page. So look at my notes because I've got a couple of things that we need to do. So say if I had a triangle. Let me see if I can get this image thing to work. Ta-da! Look at that again. Good now. Right, so obviously right angle there. I'm just going to write up here SOHCAHTOA. So let's get rid of that. SOHCAHTOA, just so we know. So if we want to work out, what should we do? Say if I knew this was 10. So this could be 10 newtons. It could be 10 meters. It could be 10 miles. So it could be a force of 10. But it's 10, right? So I won't put a unit in there because it's just a length. But it could be 10 meters, 10 newtons. And then this is a 6. 6 newtons, whatever. Obviously, this is the hypotenuse because it's got to be the longest. So I want to find this angle. So I label this because this is the adjacent. This is adjacent to the angle AD. Tell you what, I'll just do that. A, adjacent, and this is hypotenuse. Hypotenuse is always the longest on a right angle triangle. So I need to calculate the angle. Right. That's the angle, symbol for the angle, theta. Right? So I know A, and I know H, so I know A and I know H. I don't know the opposite, so I can't use these. So let's go different color. So cos of the angle is going to be the adjacent over hypotenuse. A over H. So cos of the angle is A is 6 and H is 10. Now what some people are going to do, they're going to do this. Cos of the angle, 6 over 10, and all they're going to do is they're going to do this. 6 divided by 10. Right, 3/5 or 0.6, whatever you want, right? So they'll go, the answer is 0.6 degrees. Right. Some people will do that, and that makes me angry. It doesn't make me angry. It just, I've got to give them the paper back to you because you've done the angle wrong. So 0.6, if you think about it, there's no way that is going to be so small, 0.6, right? So don't do that, and some of you will. Right, it's not 0.6. You need to do the inverse. So you need to do this. On your calculator, you need to find this, cos to the -1. Right, so to find that on your calculator, you've got to do this. See here where it says cos to the -1. So you need to do, let's get rid of that. Cancel that. So shift cos. And now you've got cos to the -1. Cos to the -1. 6 over 10. That will give us a better answer. Make sure you're in degrees, not radians. You should have a D by there for radians. A D for degrees. Because if you've got radians, you get a different answer. So, what you can do is you can just do this. You can do shift. Hang on, I can't stop that. 6 divided by 10. 6 divided by 10 is that. Look, 3 over 5. Or it's press that part. So we don't need to do that, do we? What am I doing? 3 over 5 or 0.6. So what you could do is you could do this now. So you could go shift cos 0.6. That'll give us an answer. 53 degrees. All right, so that's going to be our answer. 53 in a bit. We'll just use 53 for now. So all I've done there is I've just put, let's rub that out then, just to show you what I really did. 6 over 10 is 0.6, so that was 0.6 in there. Or what you could do is just same thing really. You could just do this, cos to the -1, 6 over 10. Because if this was 0.676, whatever it was, you know, you don't want to be rounding up. You know, you might get problems rounding up. So you can just do that now. Cos, so I'll press get rid of that. I want get rid of this. So I'll just do this now. So it's going to be shift inverse cos, put brackets like that, look, and then just do 6, and you have to come down like that, over 10. Come across there like that, close that. Cos -1, 6 over 10, press equals, there we are, 53 degrees. Tick. That then makes me a bit happier. Because 53 degrees now is in there. If you don't believe me, just draw the triangle. You could draw 6 centimeters or 6 millimeters or 6 miles. Make an angle of 53 and a bit. Don't forget we've got all that as well. So 53, and then that line up to 10. If you drew the triangle, the lengths would work out. If you wanted to, you could work out what this side here is, this opposite, if you wanted to. You could use Pythagoras, or you could use SOHCAHTOA, but we're just working out angles in this one. So that's using cos. So we'll have a go at, what should we do now? Let's do sine, because I've written it down, so we'll use sine. Don't forget. SOHCAHTOA. That's an O. So sine, using sine to calculate an angle. Go back to my little thing, see if I can get a come on. Yay. Alright, 90 degrees, just on the squint a bit. And I've got 12 here, say 12 newtons or 12 meters, whatever. And I've got 7 over here. I need to find this angle. So this side here is opposite O, and this big side is always hypotenuse, H. So I know O and I know H, so I'm going to use sine, because I don't know the adjacent, so I can't use any of them. I mean, you could work out the adjacent if you wanted to, use Pythagoras, but that's for a different day. So sine of the angle is opposite over hypotenuse, which we know is going to be 7 divided by 12. Get rid of that box. So don't do like before, don't do this, 7 divided by 12, right, 0.583, don't do that. That's not going to be the angle. 583 recurring, right? 583, whatever. That is not the angle, so the angle doesn't equal that. Some people will do this, and you will. I keep going on about it, but some people will. Wrong, wrong, wrong. Sad. Right. So as we did before, you've got to do inverse sine. So there's my inverse sine. So really, you've got to do this. Inverse to the -1. 7 over 12. 7 is still opposite, and the hypotenuse is still 12. So it's the inverse. Because no way this angle is going to be 0.5, is it? No chance. So on your calculator, just do this. Sine that. So you're going to press now Shift, Sine, then you get that, and then you want to put 7 over 12. Use a 7 over 12 because 7 divided by 12 gave us 0.5833333, so there's a bit of rounding up there. So if you put 7 over 12 in, it's going to work better for you. Get a different color, let's do red. So on your calculator, alright, sine -1, I'll do it again. So Shift that, and then put that, and then do, no, 7 over 12. Close your bracket, don't forget to close your bracket. That'll give me an angle of 35. 35 point, what should we say? Well, 35.68, 35.7. You could even go to 36 if you want to. But that's the angle in here, 35 and a bit. Not that. Tick. Happy. Da iawn. Welsh for very good, those who don't know the language. That's using sine. So we've done a bit of sine and we've done a bit of cos, and then we'll do now a bit of tan. Might as well, just for a laugh. I'll do it separate page actually. So we'll use tan for working out angles. So ka toa. So we're going to be using tan this time. Tan, right? So I've got a triangle. Let's go back to my triangle up here. See if I can get even better. Yeah. Right angle. I've got an angle I need to work out in there. And what have I done? I put 8 there, and I put 12 by there. This could be 8 meters, 8 newtons, whatever. This is off. There's my angle. So that's going to be the hypotenuse. We don't need to know that because we're using tan. We don't know what it is. This is opposite and this is adjacent. Because it's opposite and it's adjacent. Clue is in the answer. Opposite and adjacent. So right, we don't know the hypotenuse, so we can't use sine, we can't use cos. We can, however, use tan because we know opposite and we know adjacent. So I'll just do the same as we did before, just to make sure you don't. So same mistake. Tan of the angle is the opposite over adjacent, which is the opposite is 8 over 12. Now I'll keep going on about this because people will still do it. They will give me this as the answer: 8 divided by 12, 2/3, or 0.666. Oh, don't like that devil number. Don't like that. Let's get rid of that. Right, 0.6666. That's recurring. Look, it's recurring. I'll just put 0.67 there because I don't like it. That's not going to be the answer. That can't be the angle in there. So that's wrong, and that's wrong, and another. Giving you the assignment back because you haven't done it properly. So what you need to do is, like we've done before, tan -1 opposite over adjacent. Hang on, put that back there for you. Tan opposite over adjacent. So we need to do inverse tan, and we need to put in 8 over 12. 8 over 12. You could put 2/3, couldn't you? Right? I wouldn't do 0.66667 because it's rounded up. So I would do 2/3 of 8, 12. So obviously I'll do 8 and 12 because that's the lengths. So inverse, shift, inverse tan, put a bracket in like that, and do 8 divided by 12. Sorry. Tan again, 8 divided by 12. Close that. Inverse tan 8 over 12, O and A, 8 and 12, yeah, always check. There we are, 33. 33.69, I'm going to make that 33.69, we'll call that 34, just for a laugh. That's the angle, 34 degrees in there. And that's it. So when you're working out angles, you've got to do the inverse of it. You've got to do the inverse. Right? Don't just do the two numbers, the two fractions. Right? 8 over 12 or 7 over 12. It's got to be the inverse. And you find the inverse by going shift and that. So if it's sine, you press sine. Shift cos. If you're going to do the cos, it does the yellow bit, look, see, on my calculator. Shift tan. Right? So make sure you do that. Make sure you do that. Inverse. You've got to press the shift button on the calculator. So that's just a quick primer or quick reminder, or I may have sent you to this video because you've done the exact same mistake as I've been talking about. So can you please make sure you don't do that? Because if you get the angle wrong, and that's the first bit of the problem. Everything else is going to be wrong. So take your time, have a think about it, and everything will be alright. So SOHCAHTOA, calculating angles using my new digitizer. So I hope that's okay, and everything is a bit clearer. I'm going to go now, over and out. No star, I'm going to press stop.